Welcome to aminacademy.com. In electrical engineering, let us discuss about Poisson and Laplace equations. These equations are useful in the solution of many problems connecting electrostatic, especially the problem of space charge. Here the space charge means exists in the space between the cathode and anode of a vacuum tube. The two equations can be derived by applying Gauss theorems. Consider an electric field set up between two charge plates P and Q. Here, two charge plates P and Q. Suppose there is some electric charge present in the space between the two plates. It is generally known as the space charge. Here the charge between the two plates are called a space charge here. Suppose there is some electric charge present in the space between the two plates. Let the space charge density equal rho coulomb per meter cube through the volume. It will be assumed that the space charge density varies from the point of space to the another, but is uniformly throughout any thin layer taken parallel to the plate P and Q. Here, a layer taken parallel to the plates P and Q, like here. If x-axis is taken perpendicular to the plates, then rho is assumed to depend on the value of x. It will be seen from the figure that the value of electric intensity E increases with x because the space charge. Electric intensity E increases with x direction because of the space charge. Because of space charge. Now consider a thin volume element of cross-section area A and thickness delta x. Here cross-section small volume element of A area and delta x thickness. Now the value of electric intensity here, the value of electric intensity at the two opposite faces of the element E and the element or E and E plus delta E. If d by dx, now change in electric field by distance, d by dx represent the rate of increase of electric intensity. Rate of increases of electric intensity. electric intensities, then distance, then delta E equal partial derivative of dou E over dou X into delta X, and therefore E plus delta E equal E plus dou E by dou X into delta X. The surface integral electric intensity over right hand face of this element is, therefore the surface integral is E plus delta E over delta X dx into A. The surface integral over the left hand face of an element is the surface integral over a left hand face. Left hand face element is minus A into A. The negative sign represents the fact E is directed inwards over this face. The surface integral over the entire surface. Therefore, surface integral over entire face over entire surface is directed inwards over this face. The surface integral over the entire face is the closed surface, that is closed surface of is equal to closed surface of the closed surface of the element, that is E of E plus dou E by dou X delta X over A minus E into A, which is equal A into delta X dou E by dou X. From symmetry, it is evident that along Y and Z there is no field. By symmetry, along Y and Z, there is no field. We are considering X direction. There is no field. Now, according to Gauss theorem, the surface integral of electric intensity over a closed surface is equal to 1 over epsilon 0 times the charge within that surface. Therefore, the volume of the element dV equal A delta X, then charge equal rho A delta X. Therefore, by Gauss theorem, you can say A delta X into dou E by dou X, which is equal rho A rho A delta x and 1 over epsilon 0 or by Gauss theorem or dou E by dou x equal rho by epsilon 0. Now E equal minus dV by dou V by dou x. Therefore, dou V by dou x equal to dou by dou x of minus dou V by dou x, which is equal minus dou square V by dou x square, which is further equal minus rho over epsilon 0. This is a Poisson equation. This is Poisson's equation of electric field in one dimension where potential varies x-axis. In one dimension where potential varies with x, where potential varies with x. Then when V varies with x, when suppose voltage varies with x comma y z direction, that is space, then we can say, look at here, then dou square V by dou x square, dou square V by dou y square, dou square V over dou z square equals 0. Equal, not 0 here, equals minus rho over epsilon 0 equal delta square V, differential square V in a vector notation. Because it's xy direction. If in special case where space charge density is 0, in special cases space charge density is 0, then obviously you can say in general have dou square V dou x square plus dou square V over dou y square, dou square V over dou z square equals 0, of course, or differential square of V equal 0. It's a vector notation where differential square is that defined as the Cartesian coordinate. Therefore, in then we can say differential square is dou square v by dou x square plus dou square v over dou y square plus dou square v over dou z square. This is the Laplace. This is the Laplace equation of electric field. Here, this is a Poisson equation, that is minus dou square v by dou x square equal to minus rho over epsilon 0. Here, Laplace equation is differential square, that is delta square equal dou square v by dou x square plus dou square v by dou y square plus dou square v over dou z square equal to delta square. This is a Laplace equation. We have done. Please subscribe our YouTube channel.